In Lecture 23, we will be covering 4 sections, 8.1 through 8.4, starting with 8.1, complex numbers. So something you should have learned in an earlier class is that the square root of -1 is the same as the imaginary number I, so that if you have the square root of -81, you could rewrite that as I times the square root of 81, and that becomes 9I. So now let's take a look at my Open Math Homework 23, question number 1. Here in question number 1, we are to simplify this fraction, and the fraction has square roots of negative numbers. So in order to do this, you first must change each individual radical to a form with I. So looking here at the numerator, come over here. Square root of -9 is equal to the square root of -1 times the square root of 9. So that means that we can write the square root of -9 as I times the square root of 9. So that's exactly what I'm going to do right here. This numerator, I have I times the square root of 9. Similarly, the square root of -6 is equal to square root of -1 times the square root of 6. So we could rewrite this one as I square root of 6. Now it is essential that you do not combine these two radicals until you first change them over to be in terms of I. That's one of the rules of multiplying radicals with negative numbers. You first have to change them to be in terms of I. Okay, so then that gives us, for the numerator, square root of 9 is 3, so we get 3I. And then for the denominator, we see that we have the square root of 6 times the square root of 6, which is 6. And then we have I times I, which is I squared. So one of the things that you should have also learned, in addition to learning that I is equal to the square root of -1, is that I squared is equal to -1. So that means that we can replace this I squared with -1. So now let's change back here to purple, and we have then 3 over 6, which is 1/2. And then we can replace the I squared with -1. So then that reduces to -1/2 I. And so there is your final answer. Okay, so then moving back to the PowerPoint presentation, we want to look at how to add and subtract complex numbers, which is really easy. You just need to add, or if this is a subtraction sign, subtract the real components separately from the imaginary component. So you see that 4 plus -5 is -1, -5I plus a positive 8I is a positive 3I. So now we can go ahead and look at number 2 on my Open Math. And number 2, we have a -5 minus 1, which would be -6. And then a 5I minus a -7I is, of course, 12I. Now here you want to pay attention. It says write the result in the form A plus BI. You may have been wondering about the previous one, why I wrote the 1/2 out in front of the I instead of writing -I over 2. And that is because for standard form you want to have a coefficient out in front of the I. And so likewise we see here at first the real component and then the imaginary component. So now back here to multiplying complex numbers. When it comes to multiplying, you're going to follow the same steps of FOIL as you would with any other binomials. 5 times 2 is 10. That's your first. Outer is -35I. Inner, 6I. And last, 3I times -7I is -21I squared. It's at this point we can replace I squared with -1, And then you can combine like terms as well. We've got negative 35i and a positive 6i. And then 10 minus a negative 21 is a positive 31. So there is standard form right there for multiplying complex numbers. So now we'll look at number 3 from my open math. For question number 3, we want to use FOIL. So negative 1 times 4 is negative 4. That's first. Outer, negative 1 times negative I is positive I. Inner, negative 3i times 4 is negative 12i. And last, negative 3i times negative I is a positive 3i squared. Next we have negative 4 minus 11i. We replace the I squared with negative 1. So for our final answer, we have a negative 7 minus 11i. Make sure you write it here in this standard form, a plus bi. Now when we come to division, we're going to look at two different types of division problem. One type is when the quotient is a monomial, so to speak. It's not technically a monomial because this is not a polynomial, so I shouldn't have used that word. But what I mean to say is that it's a single term. When you have a single term, what your goal is to get an I squared. So by multiplying by I over I, we do get an I squared, and since I squared is equal to negative 1, then negative I squared is equal to positive 1. And so we can write this as 15i, or standard form would technically be 0 plus 15i. So now we can look at question number 4. And here, all we need to do is turn this denominator into something with an I squared. So then if we multiply by I over I, our denominator will have an I squared, and the result will be 2i plus 2i squared over 6i squared. So next we replace these two I squareds with negative 1. And then what we want to do is we want to split this fraction into the real component and the imaginary component. So the real component is going to be this negative 2 over negative 6. So we have a negative 2 over negative 6 for the real component, and then for the imaginary component you have the 2i, which is actually 2 over negative 6 with the I always off to the side. And then we can simplify this further, of course, to be a positive 1/3, and then we'll be subtracting 1/3 with I. So you really can't just look at this and guess what the answer is going to be. That's a little difficult to do. Now, it is true that you could also do this by splitting this into two separate fractions. So there is a different route to go, where you could have the 1/3 found out first, and then you could simplify the 1 over 3i separately. But you still have to go this route by multiplying the I over I, and that's how it changes from being a positive to a negative. So you're going to want to go this long route anyway, so that you get the accurate answer. So now for question number 5, let's look back at the PowerPoint presentation for an example. When you have two terms in the denominator, what you want to do is multiply by the complex conjugate. The goal of multiplying by a complex conjugate, the goal of multiplying by any conjugate, is to create a difference of squares. Because when you have a difference of squares, in the case of radicals, you can get rid of square roots, and in the case of imaginary numbers, you can turn an I into an I squared, which of course is then a real number. So that's what your goal is, and then you would continue with these steps. You can look back on these steps if you need to. Go ahead and pause the video if you need to. But I'm going to otherwise move on now to question number 5. So here what we want to do is we want to first ask, what is the complex conjugate of negative 6 minus 4i? And the answer is negative 6 plus 4i. It's the middle terms that switch signs. So now we're going to go ahead and use that same FOIL process that we did earlier with multiplication. And using first, outer, inner, last, I've already combined the outer and inner here to negative 32i. The last is 16i squared, which is 16 times negative 1. Likewise, for the denominator, we have a negative 6 squared, which is 36, minus 16i squared. So this will become a positive 16. So a positive 16 and a positive 36 is a positive 52. So for the real term, we're going to have, let's see, 12 minus 16 is negative 4, so negative 4 over 52. And then for the imaginary component, we have subtraction here, so that's minus 32 over 52. And then the I goes off to the side. And then we want to reduce these values, of course. This is going to become negative 1 over 13 minus, these are both divisible by 4, 8 over 13. Notice we're writing this in standard form, the a plus bi form. And here it is with the typed up answer. Okay, so then for the next problem, we're going to be looking at how to simplify powers of I, and as long as you know that I is square root of negative 1, then you know that I squared is negative 1, and then you also know that I to the 4th is positive 1, because I squared times I squared is I to the 4th, and negative 1 times negative 1 is positive 1. So here, if we have I to the 33rd power, we're going to separate this into I to the 32nd times I to the 1st. So since 32nd is really the 4th, I to the 4th raised to the 8th power, we can replace I to the 4th with 1, so then we can simplify this down to I in math number 6. I to the 95th power, so what we want to do is write I to the 95th power as some sort of power, I would say, of an even. Okay, so let's say 92, that is divisible by 4, so that's good. And then we could also multiply this by I squared, and then this is I to the 1st power. So you can actually break it down into multiple pieces if you want. Well, see, I to the 92nd power, since 92 is divisible by 4, it's 23 times 4. We say that's I to the 4th power to the 23rd power, and then we already know that I squared is negative 1, and then we have our regular I afterwards, of course. Now we replace I to the 4th with 1, so we have 1 to the 23rd power times this negative I, and so our answer then is going to be negative I. 1 times negative 1 times I is negative I.